right, good afternoon, everyone, and welcome to our first session in our new IDs and Diagnoses series from the State Master Gardener Office. And this series is featuring all of our Virginia Tech labs. All microphones will be muted during the session, but please feel free to use the chat box to ask any questions you might have for our speaker. And we'll get to all those questions at the end of the session. All recordings from the series will be posted to our EMG webinar archive, and I will post that link in the chat box for anybody who doesn't have it. We are very excited to welcome Steve Heckendorn for our kickoff session. He is the laboratory manager at the Virginia Tech Soil Testing Lab. So welcome, Steve, and thank you so much for joining us.
Yeah, hello, everyone. And I'm unmuted, and I'm going to start screen sharing right away. Or I'm looking at me. And go slide presentation. All right. Oh, some of the Zoom stuff over. I don't know what it does for you, but it overlaps some of the top of my slides, but hopefully we'll get through that. So, all right. Well, welcome, everyone, and glad to have you join us. And the Soil Testing Lab is part of the academic unit of the School and Plant Environmental Sciences. And as this group knows, we're also part of Virginia Cooperative Extension. Again, I'm Steve Heckendorn. I run the lab under the direction of Dr. Rory McGuire. The lab's located in Smythe Hall on the main campus of Virginia Tech in Blacksburg. We began operations in 1938, so we've been around, 83 years? So. Now, soil testing, it's used to estimate the nutrient availability in the soil. The end goal is to come up with fertilizer and lime recommendations. Now, testing is available through this lab, my lab, and also private laboratories. Now, if the grower is required to have a nutrient management plan, then they better make sure they're sending their samples to a lab that's been already approved by the state's Department of Conservation and Recreation. Now, most labs have soil fertility labs have a package deal that answers the basic soil fertility questions. Ours is called our routine test. We essentially run that on every sample, which is normally over 50,000 samples in a year. Now, this last calendar year, we were just short of 50,000, probably because of COVID. So our routine test package includes the determination of a couple pHs and the plant available, not the total level, but the plant available levels of 9 elements or nutrients. And it also provides an estimated CEC or cation exchange capacity. All right, early on in modern soil testing was a more of an educational tool to help promote the benefits of using lime and fertilizer. Today, it's also a tool for managing environmental risks. Now, in a farm situation, main thing is probably going to be like the soil test phosphorus level. It will be one of the parameters to help determine if any more phosphorus should be applied to a farmer's field, including like applying any more manure. An urban situation may look like this. I believe a professional fertilizer applicator cannot apply any phosphorus to an existing turf unless a soil test shows that it needs phosphorus. And about a third of our lawns test low in phosphorus. So getting that phosphorus built up will help ensure you have a good ground cover, which would help prevent this pictured here, soil erosion with nutrients going down the storm drain along with it. All right, so we only do 3 tests. Again, we do have our routine test, answers the basic soil fertility questions. I've got here, be careful it's best not to include nematode soils with their soil samples here. At the very least, if they are using the nematode boxes and forms, that's got to get over to another building. So that could delay testing. The other thing is hopefully they don't use our soil box container sample, because the nematodes got their own and they need about twice as much soil material to do their testing as we need. And the first thing we do is dry the soil down, which ruins it for the nematodes. So otherwise, we just do 2 other tests. Well, you'll hear us in the lab call them extra or special tests. One is an estimation of the organic matter test. And these extra tests are not normally needed, and they will slow down the process. If they need a quick turnaround time, this will slow it up, and it's usually not needed. Now, we probably, I'm guessing, organic matter test, more soil characterization test, was first incorporated in this lab for farmers to adjust their herbicide rates. The more the organic matter, the more it ties up the herbicide, the more you're going to apply the herbicide to be effective. Or if someone needs to quantify, like a contractor, exactly how much organic matter is in the soil material they're bringing in, to say some contractor is building a new ball field for some city, good chance the city's specified they want X amount of organic matter. Well, they have to show that in a soil test report. That's what it is. Or say VDOT's, some has a contractor and they disturbed a wetland, making a new highway interchange, and they want to put that back as close as they can in the wetland. They got to show how much organic matter is in the material they're bringing in. Excuse me. Or if you want to compare levels at different times, you slowly, like if you switch to tillage system to a minimum or no till situation, you want to see if you're building up organic matter over time, and is been requested most by home gardeners. All right, the other one is soluble salts test. Again, not normally needed, mainly needed and where you're growing things in containers. So they're easy to over fertilize. And if it's not sitting out where you get rainfall on it, and you just add some water and never add, a good leaching amount of water to that soil, excess salts can build up. Other problem is when you've banned a fertilizer too close to a seed. A drought will just make things worse. A drought situation will just concentrate the salts that are out there in the soil. And so that will exacerbate a problem. You're more apt to see salts problems during a drought. Salts from external sources. Well, if you over fertilize again, say you're irrigating with some well water, so that's hard, and you just add a little bit of water at a time and not much to saturate the root zone, then that can build up salts. I got VDOT down here because a true story. I heard a total truckload of rock salt got dumped on somebody's lawn once. And well, of course, come spring, their lawn didn't green up. It killed the lawn. So after several good leaching rains, they sent in, they would keep sending in, say once a month, a sample to our lab. And so we could tell them when did the salt levels drop enough out of the top several inches. So it was, beneficial to not too soon to reseed or sod before the salt level dropped. Again, you're along the coast, you got ocean salts from storm surges and brackish waters. All right, I usually break down the steps of the soil testing into 4 phases. There's sample collection. Now, very important step, but we only serve an educational role in this, and this is where master gardeners can help out a lot. The next is analysis. Sometimes I break it down into 2 parts. First, the soil preparation is a significant amount of time and labor in here. And then the analysis, the part where you think of a laboratory doing, the wet chemistry, generating the numbers. And the last 2 here, I sometimes group together. So once you got the lab numbers, there's a reporting that to the client or the grower. And then they got a number and say, well, what's that number mean? Interpretation, is that good or bad? And then recommendations. So what do I do about it, if anything? So, all right, the first step, probably first really decide what lab you're going to send your sample to. Get their forms and their sample containers. Ensure you're sending them the amount of soil material that they want. We have a box, some have a sample bags. It just always never hurts to first decide what lab you're going to send it and get their stuff from them. For us, you would need one of our forms or soil sample information sheets and our sample box container for each sample you're sending to the lab. We have half a dozen forms covering over 150 different crops or plants. Okay, our lab's website, good to remember. So you forget things, don't forget this. soiltest.vt.edu. You can get a lot of information there. It has our soil test notes that supplement our reports because it's only 1 sheet of paper report, only so much information you can put on there. Sampling instructions, all the forms, And you go to the lab's website. It will help ensure you that you have the most recent form to use. We get forms in that are years old or decades old. I think last year hit a record. We got a form that was 38 years old, almost 4 decades. Some things have changed in that time. There's lab procedures and example reports online. Okay, so choosing a form. First decide what do you want to grow. So I've seen cartoons, soil test, and then tell me what you want to grow. Well, this soil testing is one thing. You can adjust the fertility to what you want to grow. So first, you pretty much want to decide what you want to grow, then select the form that has the plant or crop code on it that's closest to it. And then I got down here the next 2 most commonly used forms. Well, around 70% of the samples come in with a commercial crop production form. We're getting slammed with those now, more than we can process in a day, coming in every day. So again, they're available online, and fillable means you can download it, and then you could type in, enter in things that don't change. This is good for especially farms sending in 50 or 100 or more samples at a time. You can type in name, address. Now, it's really good. Most of our samples, maybe 90%, are now going out the reports by email. Well, guess what happens when you can't read one of the letters, or is that an L or a 1? So it's great when the email has been typed in. It helps ensure it actually goes through. With this group, the next thing we're constantly running into is usually people either miss it in their email. We're getting calls all the time. The email address was correct, but we're guessing a lot of time it goes into their spam or junk filter. The second most used form are geared to the homeowner, the lawns, gardens, fruits, ornamentals. We get about 20-25% of the samples come in on one of these, so it's the second used most form. Now in the lab, we print them on green sheets, but of course, anything can come in white now. A homeowner prints it off on a computer. I don't have color paper at home. I have white paper, but we do try to color code them in the lab. There is a greenhouse nursery production form. There's a golf course and industrial lawns form, but I don't have pictured. There's a surface mine form, and there's the 6th form was the research form. That's really only for internal use. All right, the forms, they'll tell you things like where to send the sample to, which is directly to the lab. And so it gives you our address, what tests are offered, what fees are charged at all. We just had today at the bottom, there's an out-of-state fee column for the fees and an in-state or an out-of-state. And so every now and then, I think people just go all the way left, read the out-of-state fee and overpay. Also payment information, like how do I write a check out to? Who do I write a check out to? Treasurer, Virginia Tech, it always is. So the client's responsibilities, typically they're the ones collecting the sample and they're the ones to get it to the lab. Now, the greatest potential for error in soil testing is in taking the sample. I'll partially say that because I have no control over it, but it could be pretty challenging even for a professional because there's a lot of variability out there in the field, and it could be challenging to get a representative soil. So the next several slides I'm going to go over. I don't want to get over in detail, but the sampling part's so important, and I'm going to spend some time several slides on that. So keep in mind that a sample is probably a pound at most, maybe more, half a pound of weight may represent out in the field around 200 million pounds of soil per acre. Okay, sampling instructions. In a nutshell, in a summary, on the sample box there's some, and that's geared more to when you're sampling acres of land. Now on the green or the lawn garden homeowner sheet on the back side is some sampling instructions, and that's geared again to more towards the homeowner. You're sampling, you're talking areas of 1,000 or hundreds of square feet. Now the lab's website has up here one of the tabs, I opened up, is sampling instructions. And you go down there, there's a publication with more detailed sampling instruction. This pub is geared towards the homeowner. Next page, this one's geared towards the farmers. You can go get that, download that, print it. So again, I'm not going to go through everything, don't have the time. First, there's various sampling tools. You need one of those. If you're like a homeowner, only taking a sample or two every several years, you probably just got a shovel and a trowel. But doing this step by step, I'm not going to go through the procedure, but that's more time consuming. So if you're taking a lot of samples, it's worth investing, get some kind of sample tube to do sampling. Will save you a lot of time. All right, so of the sample box you send to the laboratory for testing, it should just represent one management unit. And there's natural and man-made field variability. So natural, like in a farm situation here, larger, with change of topography, upland, sloping, bottomland, the soil is going to change with that. So ideally, it's best to sample those areas separately if you can treat them separately, or sample them separately if you treated them differently in the past. Like here's this area is limed and this half was unlimed. You want to sample them separately. If it's an odd spot, like this low spot, you may want a separate sample, but if it's small enough, if I tell a farmer just to ignore it altogether, you can't treat it differently. It's not worth the investment to treat it differently. You could apply manure to one field or not the other. And of course, cows will naturally probably just apply more manure towards closer to the barn. In a homeowner situation, may look like this. I used to own a house where like, oh, it's a nice level lot. Well, I found out why. The front was level and across the street was a steep slope. They had they had pretty much removed the topsoil in the front yard was 2 inches of clay with chert underneath. So it always showed drought stress first before the backyard, which was less compact, had more organic matter and loamy soil in the back. So I would definitely sample the front and back of that house separately, at least initially. Again, you're on a lower lying spot, like the farm, it may look different, it may look more disease oriented or something, probably because it stays wet all the time. That, it's large enough, a side lot here, you probably want to sample separately. And now garden, you're going to want to send in a separate sample to the lab because you're going to have different inputs and outputs. You're going to probably be fertilizing it heavier, and then you have more nutrient removal. When your grass clippings, it's time to recommend just recycling your grass clippings back on the lawn, putting your clippings back on the yard, recycle the nutrients. But in the garden, you're removing flowers, vegetables, fruit, so you're removing nutrients. So you want that to be separate. And another slide or two here, I'll get over why there's zigzag patterns here, because this area, like vegetable gardens, one sample you send to the lab, but each yellow spot here is a sampling point. Because even in a garden, a small garden, you can get a lot of variability. You still want to probably hit 10 spots of sampling. So I could tell you probably did it right if your box is full and you had to throw some of the soil material back on the ground. So, so again here, a zigzag pattern, not truly random, but in a practical way, it gives you a good representative sample doing a zigzag pattern. What depth for no-till situation, you're usually doing 2 to 4 inches. For a tillage situation, you're usually going to sample down to the tillage depth. For trees and shrubs, most of the feeder roots are in the top half foot, so you want to go down that far. And hopefully everyone can see in all those situations, you always want to remove any coarse fragments, stones, twigs, any thatch or mulch on surface, and get down here and start your sampling point at that point where you're getting the mineral soil. So remove thatch and mulch, brush it aside before you start sampling. So, all right, when to sample. Well, you can sample anytime, even if the ground's frozen, if you have one of these rigs with a hydraulic probe, but usually don't do it when it's frozen or too dry, because it's really hard to get down past an inch or two when the ground's that hard. And so, or worse, you're not even consistent in the depth you're going down to. So, and on the flip side, it gets too wet. It just said you want to take at least 10 or like a dozen spots, and then you want to break it up by hand and thoroughly homogenize that soil material from all those spots. So you make one representative spot average of all those sampling spots. Excuse me. But when it's too wet, it's just going to make a muddy slurry, and it's hard to mix and do that. All right, recommended time, I say late summer through the fall, because at least two reasons. Right now, I tell everybody that samples have taken off. If the weather stays nice, we'll be slammed with samples well into April. So labs, surprise, surprise, are like us, are always busiest right before planting. And they said, what haven't I done yet? Soil tests. People say they're in a hurry. Well, everyone's in a hurry come springtime. The other thing is when the soil test report comes back and recommends you apply some lime. Well, lime is slow reacting. That's one question I still ask on the homeowner form, because it can take a year and a half to react, and we give a lime credit for that. So the sooner you get it out there, the better. So if you can get the lime out there before winter sets in, then you go through these wetting and drying cycles, freeze and thaw, it freezes, the lime maybe goes down through those cracks and stuff. It just helps changing the pH. So it's good to have that lime out before winter. All right, additional guidelines, plant before establishment. Yeah, so again, lime, I think I just said, and phosphorus, when you apply it, if it's just to the surface, it's only going to react or affect a fraction of an inch of that soil on top. It will slowly maybe work down some, but not. So if pH is really low or phosphorus is really low, ideally, like you can add that and till it in, work it into the root zone before you plant whatever turf or your garden. So areas tested at least once every 3 years. Well, it's a requirement by DCR if you need a nutrient management plan. If you're not, I'd say if you got heavy clay soils, that pH won't move as fast, but you'll need more lime when you do need to apply it. And you could probably go 3, 4, maybe even 5 years between soil testing. In a very sandy situation, low clay, low organic matter, it probably may be good to do every 2 or 3 years because the pH will bump up and down quickly. No buffering capacity. Won't take as much lime, but you'll have to put lime on more often. Do not wait till last minute. Again, that's because the lab's always busy right before planting. And recommendations are only as good as the sample collected and information supplied. So this can save time, but taking a good proper soil sampling critical, and getting a representative one does take time. Remember, garbage in, garbage out. So if you have an unrepresentative soil sample, your test results are really going to be, they may be misleading rather than being good. And then here, this is mainly for probably a farmer situation, the farmer's form. Of all these things we consider in the fertilizer recommendations, only one, the soil test level for nutrient analyze, is being supplied by the lab. Otherwise, our fertilizer recommendation software is considering factors that have been provided to the lab on the sample information sheet. So it's important, the more information you give us, the better the recommendations. So that's mainly for farmers trying to get things, shave a buck per acre, and not just in the ballpark to stay in business. All right, let me grab a drink. All right, let's see. I've got a panel of our box, and like the homeowner form. I guess important critical things, the name on the box, the name on the form, hopefully match. We'll use that to, if they're separated or they're mailed together in the box, just to make sure we set things up in the correct order. The forms will be assigned a unique lab ID, and they'll go upstairs to the office area and separate from the sample. So we want to make sure we can always go back, match it up, and keep things set up in the right order. It's the name, and there's 5 characters you can put in there on the box and the form so we can match them up. So again, like I was sampling on that house, the lawns, I could front in here and one, back on the other one. So we don't care what this is. We just want to make sure it's the same on the form and box to match them up. But this is for when the grower gets it back and I got the front. Oh, this is the results for my front lawn. Yeah, it's just 2 inches of clay and it needs more lime. So and I know the other one's for my back lawn or garden or whatever, however you want to do it. You can just do 1 through 10 and just make sure you have that. Probably, oh, well, I'll say this later, but if you're going to get recommendations from the lab only provides what's been computerized already. So probably maybe like 180, it's over 150 plant codes. So you need to select a plant code and put it in here, the 3 digits, to get recommendations back. It's computerized. The good thing is you get that back right away. Now, I always point people back to a local extension agent or master gardener to help them fine tune or help anything on that. Probably the most used one, very common, is 202. It's maintaining cool season lawns. So, all right. Oh, yes, drying samples. If you get out, like, I don't know where all you are, but we had a lot of rain here the last 24 hours. You sample, and it can be, samples really wet. It'll cost you more in postage. And it's so wet, we may have to set it aside even. So let it air dry and then send it in. It doesn't have to be super dry. It could be damp, but not soaking wet water running out of it. So the main thing is air dried, do not oven dried. Don't be tempted to put in your microwave or conventional oven. Overheating it could change test results, mainly in certain mineralogy, could be potassium. We could end up measuring more potassium than we want to because it won't be available the next growing season. So you can overheat samples. So you want to air dry. We had some heat, but air dry. With this group, yeah, I was going to say sometimes people stick a check or information sheet in right against the soil. Well, that soil looks dry, but I'll tell you, there's some moisture in there, and that paper will suck it out of that, take it, absorb it out of that soil material. Next thing is I got checks with the ink blurred, and you can't read anything, or the paper's tearing apart. And so you stick it, fold, as it says, some of the flaps first, or lay it in there, or put the check in a Ziploc bag, something, but don't put it up against the soil in the box, even if it looks dry. And air dry, just let it sit out, spread out, or with a box open for a couple of days, and let it dry maybe before shipping it off. Okay, let's see. I saw once a set of questions for us, certified crop advisor questions. And this one I saw, the most precise component in a soil testing program normally is, and the answer is laboratory analysis. So we got the most control probably over there. All right. Went through the phase, the step of collecting the sample. I'm going to try to go, how are we doing on time? Try to go fairly quick, yeah, through this part, but the next is the lab part. Now this is where I could definitely talk too much, but here's our main entrance, our door. And if you call our a lab, just make sure you know we have 6 technically, well, 3, technically 6 rooms. 2 of them, the prep area is in the basement. So they're also on 2 floors. So the sample box could be that we might check what's written on the side, maybe down in the basement, the information sheets up in the form, and the check's already been deposited to the bank. But first they get hauled down here, U.S. mail. U.S. mail goes through campus mail. That could add another day in getting to the lab. So the U.S. mail delivers a central location to campus mail, and they deliver it. And then UPS and FedEx, UPS is usually in here about essentially every day and bring it straight to the lab. So then it goes in the setup room. We set things up in trays of 30 samples. There's like 2 quality control samples in each one, leaving 28 unknown client samples. It will next spend 2 nights in these drying cabinets where we force blow warm, dry air across it to help dry it down. And then, so like if you get in here on Monday, we get set up on Monday, you'll spend Monday, Tuesday night in the dryer. And like Wednesday morning, before I even get into work, someone's putting the soil sample through here. There's stainless steel slabs, spin around, break up those clods, those PEDs. Goes down to we sieve it through a 2mm mesh sieve. It goes through that, goes back in the soil. I mean, here's some on top of the slide is pictured, like there's some soil cores. They didn't really break them up to homogenize it, but that's before, and here's an after picture after it's been air dried, broken up and sieved. And after that's happened, we take 2 subsamples for the generating the numbers. The analysis, we take one for pHs and one for nutrients. So I don't really want to spend too much time here. But we sign a lab ID to it. They go, information sheets go upstairs. We can start entering in where do they want to grow, where do they want the report to go to, and the pHs we've automated as much as we can, because like the month of March, we may have 20,000 pH determinations to do. So because all of them get a soil water pH, and then there's a buffer index on the form. That's a buffer pH. Anything under a pH of 7 gets that. So most of them get buffer pH. I can spend too much time here. Yeah, let me press on because I want to get to some other things at the end. I know the one subsample was for extraction. We had our extracting solution, put it on a reciprocating shaker for 5 minutes, dump a row of 10 at a time. So anything we can do to minimize individual handling. We have to keep time and costs down in this lab, or a mass production lab, and people want quick turnaround time. So we dump and row of 10 at a time on filter paper, just gravity filtration. Then we discard the solid phase, transfer some of the solution to this sample cup, auto sample rack. It's going to go in an ICP. Here's the samples. So that's like 180 extracts on there racked up on this auto sampler. We'll get fed into this plasma. You come through the lab, we can spend 5 minutes easily. Instrumental class, couple hours talking about these instruments, but in ballpark, this one ICP instrument will determine all 9 elements we want to report reproducibly with a background shift too on a part per million level. So it's a real number cruncher. So the nutrients are by that. Okay. So processing time, I think, yeah, essentially, I said a lot of this already, but mainly just the routine tests. Extra tests will add more time. It's 3 working business days in the lab. So once we get it, again, if you got it set up on Monday, of course, samples we got yesterday, they haven't all been set up yet. So it may not be to tomorrow. We're getting slammed right now, various samples. So, but if there's no backlog, it gets set up on Monday. We'll be grinding it and testing it on Wednesday. And if you have an email address that we can read and enter correctly, by end of that day, you'll have your results. So like half a week turnaround time for routine tests. So otherwise, you got to allow time for shipping your samples into here unless you can walk into the lab. And if you don't have an email address, if it doesn't go through, it keeps bouncing back, we can't figure out, we'll remove the email, and then it will get another site on campus. It will get printed soil test notes will be stuffed in an envelope, and it will get mailed by the U.S. snail mail, U.S. Postal Service. So, excuse me. If email provided, I covered that. Add time again. I think I covered everything. All right. Web access to soil test reports. All right. I'm going to go through this mainly so you know this exists. Last I know, volunteers like master gardeners can't log on to the site, but any paid extension workers should be able to. So it's accessible by extension personnel. Samples are immediately available. Let me just start showing you. I think I got some slides to show you that. So to get to that, you go to, again, the lab's public website, soiltest.vt.edu. If you click under have questions, most people on the tab have to click on the more before they hit have questions. And if you see my mugshot, then you know you got there. And then on the right side is sort of internal use. And in the center one, you click on VCE soil test reports for extension employees only. They click on that, they get into this search application. There's also a link to other resources that are more for internal use. Again, unit administrator, extension agent, and extension employee should be able to do this. This is the same way we search for it. We can search by unit, time period, various things. So sometimes people can't find it. You may want to call our lab. We use the same software, we just got more experience doing that. Like nothing showed up. Well, make it more general. Too much showed up, Don't put in Heckendorn, people spell it Heckendorf, just do heck. And there's under search tips, there's ways to search and there'll be heck and hecken and different names will come up. And usually that's a better way. And you can search the entire state too, not just a unit, because sometimes it just some reason it gets coded from one extension office, local office to another one instead. Search results come up like this. I mean, here the bottom one, it's you can't generate the report yet because it's incomplete. Does have the pH, and I could tell that Ellen we have Ellen's sample because it's been typed in here. You can tell. Rest of these are farm samples completed. These C reports are going to be lawn and garden reports. You can collect certain ones, add it to a cart, and you can generate the report, print it out again, or just generate it. And often now we're just emailing the report. So that's another way the local offices can do that, generate the reports again. Once they've gone through and do that, well, I'm on time. All right. What's good if someone does have a soil test report, if you're communicating to the lab and you really want to uniquely identify that lab, like, yeah, we have several Joe Smith samples, the upper left lab ID, that's a unique number for 10 years. And I guess this is getting an older slide. 14 was the year 2014, so it's good for 100 years. So most of the time you just got to give us these last numbers. You call up now and say it's 46,000 something. I'm going to know it's from the end of last calendar year. If you're talking 4,000 or 5,000 we're around right now, it's under 10,000. I know, yeah, you're talking this year, calendar year. I can't see it because of some Zoom covering, but at the top center says the date completed. It tells you what soil test notes they should be looking at. They all have one explanation soil test reports. For lawn, a lot of the recommendations in note 17 or 18. And again, this is stuff in a nutshell. We're always trying to get people to make contact with their local extension office. A lot of our growers, we find out, don't know what extension is, or that there exists a local extension office. And often we're letting them know about that. So on the upper left, it says questions, contact. So whatever unit office that sample is associated with, on the report is the address and the phone number for that unit. So that local extension office. Otherwise, recommendations, again, they're only provided by the lab when a computerized crop code has been selected on the sample form. And there's always additional recommendations available outside the lab. So that's publications, there's the Mid-Atlantic Commercial Vegetable Production Recommendation Guide. There's some things in there, like it's just not really grown in Virginia, but someone wants to, but it may be in there, but not in our computer software. Also online, there's like the Verticultural Extension Resources website. So those are places people go. All right, now I'm going to get more into the interpretation part, and let me grab a drink. All right, there's really only three main concerns when you're talking about lawns, gardens, ornamentals, landscaping situations. You buy a bag of complete fertilizer, usually probably garden fertilizer like 10-10-10. That's N, P, and K, nitrogen, phosphorus, potassium. So first, nitrogen, which we're not testing. I think I'll hit on that in the next slide or two. But first of the three things important, apply the right amount of nitrogen at the right time. The right time is when the plants could take it up and use it, and it won't get leached down into groundwater. So next, keep phosphorus, potassium. You're not trying to shave $1 per acre. It's mainly aesthetics or so. But you don't want phosphorus, potassium in the low range. Just get something. Usually we're shooting for, because of field variability again, to get in the M plus H minus, the high end of medium, low end of high is what our recommendations usually shoot for. And the third item here, keep the pH in the proper range. That's probably the number one thing people to do a soil test. People think, but I got clover and this, that. It's pretty much a guessing game. You want to get an accurate pH. One, there's no quick fix to it. Again, if you're just throwing it on the surface and slow reacting, but it's so important. Let's see, I was going to say something else, but oh well, I can't think of it now. So keep pH in the right range. Oh well, I may hit on it in another slide, but So get your nitrogen on the right time, get P and K out low, keep your pH in the right range. All right, a soil test is best for nutrients that have low mobility in the soil. So they stay in the soil. When we're not testing for nitrogen, or here's the top one here, nitrogen, sulfur, and boron. They're very mobile in the soil. That's how you hear nitrate form nitrogen to form nitrates. It's going to easily leach into groundwater. You hear environmental effects to that. They're not too useful. They're so mobile. You test it today. They're here. I've given the analogy of soil testing is like looking in the plant's refrigerator. So these elements are like the milk in the refrigerator. They may be here today and good and useful now, but it won't be that long before that could all change. And like if you put nitrogen out in the fall, you don't want to do that on your garden or a farmer, because if you get rains like at least we had here now, it would just leach that away before the plants could use it. So again, you put on the right amount of nitrogen when you need it. The elements in the middle here, the cations, potassium, magnesium, calcium, they're like the other things in your refrigerator. The phosphorus and the micronutrient metals are like in the freezer section. Well, they may quickly form insoluble precipitates in the soil. So they pretty much stay there unless the refrigerator's eroded away, the soil's eroded away, or you're putting on so much phosphorus for like manure applications or so that you just can't, the refrigerator, the soil just can't hold it anymore. So let's see. All right, the main reason you want to keep usually the pH in a slightly acid pH is for most plants, because that's where pretty much all the nutrients, essential nutrients for plant growth, are water soluble. They'll go in the soil. If it doesn't go in the soil solution, the plant roots can't take it up. So it's not plant available. It may be sitting in the soil, but if the pH is too high or too low, it maybe won't be available at all, or be so available it becomes toxic. So too much of a good thing is possible too. All right. Taking a drink of your reading that. Nutrient-wise, why is it good to chorate a lawn? Now, physical properties, it's good, like soil compaction. It helps with that. It's one of the good things beyond what our lab gets into. But for soil chemistry, fertility, it's because, well, one is if it's a lawn, these mineral nutrients, NP and K you're throwing on, just go on the surface. Well, this can make a hole, and you get rain. It could help move the fertilizer applied to the surface down into where the grass roots are, the top 2-4 inches. And plus you're throwing some soil up on top of that fertilizer. But there are 3 non-mineral nutrients that we don't fertilize: carbon, hydrogen, and oxygen. Plants get those through air and water. So this creates pore spaces for air and water to go through. We usually think of an ideal soil material to grow in has half its space as pore space to allow those water and gases to go in and place for the roots to grow. All right, generally in Virginia, the pH is going to be pretty much naturally between 4 and 8 under natural situations. Carbonates will precipitate, keep it probably going, from hitting 9. The pH it is natural. East of the Mississippi, where rainfall exceeds evaporation, soils will naturally get more acidic over time. So every so often, to keep soils productive, you got to add some lime, but you don't want too much too soon. Too often is not good either. Perspective here, vinegar and like sodas, Coca-Cola are around a pH of 3. So let's see, I get into, okay, the critical level. Usually, if the critical level is the soil pH, water pH gets below 5 for most plants, that's critical, because that's where the solubility of aluminum starts increasing, and then it skyrockets. And jump ahead. Plants do not like too much aluminum in the soil. Let me go back. So aluminum will become toxic to that. You could probably go down a little lower in sandy soils. That's good. It's hard to regulate the pH because they don't have clay. They got less aluminum. Sandy soils could probably tolerate a slightly lower pH than a real clay soil. On a lawn, we like lawns between a pH of 6 and 7. And there's reasons besides, aluminum toxicity or things. One is keep it above 6. You keep microbes active that decompose dead roots. That will help minimize the buildup of thatch. And we usually have a target pH to lime up to 6.5. One is homeowners probably aren't going to sample that often, so it'll keep dropping. So you want to take it up somewhat. It's sort of the midpoint. So if they over apply, hopefully they don't go alkaline and above 7 and cause micronutrient deficiencies for what I was talking on that one graph. And it's also, if it's like a lawn situation, you're only throwing it on the surface. So it's even harder to change once it gets out of the range where it should be. Now, things like azaleas, acid-loving plants, they can tolerate down, ideally they like 4.5 to 5.5, but people sometimes think I'm crazy that you can get too acidic even for an acid-loving plant, but you can. I showed you that. Oh, okay, so if you get a pH below 4, that's probably not a normal natural situation. And I've ran into 2 situations, phone calls where it's below 4. And our report, actually, I think now it does not give a lime recommendations and says if your pH is under 4, you need a potential soil acidity test. And because 2 things I ran into. One is like I hear, oh, they've had this, like azalea, some acid-loving plant for years. So this is not new construction or new planting. It was doing okay, now it's not. And I ask them, well, do you apply something to keep driving down that pH? He says, oh yeah, they do that every year. And it's like, okay, you've been successful. Stop doing that. So stop putting on any more of that. And actually you may have to put a little bit of lime on or something. Now, the other situation I run into, I hear there's new construction. I'm trying to establish a lawn. It's like, okay, especially if it's along the east part of the state. Let me grab a drink. Excuse me. What happened here is acid sulfate weathering potentially. So in other words, there's ground movement. That's why it's hard to get a good representative sample around a house, even though it's maybe less than an acre. There's been a lot of disturbance through construction of that. So, they dug out, well, I'm not going to get into that anymore. But anyhow, if they dug out like the mineral pyrite, hydrogen sulfide was buried under the soil, but now it's on the surface, getting exposed to water and air that hydrolyzes, oxidizes. Essentially, you create sulfuric acid. So, and the pH goes down below 3, 2, 1. So, really goes down there. So here's sod. The second time they laid sod, a lot of waste of time and money. It just died right away. So another key of that, I could see that's probably what's going on is getting down the slope, and then it hit a concrete sidewalk. Well, those carbonates in there probably neutralize some of that acidity. So the iron that was then soluble becomes insoluble, precipitates out, and you got these brown iron stains probably on the sidewalk, and then it raised the pH. So on the other side of the sidewalk, where's the cursor? On the other side of the sidewalk, you have this little green strips that actually something can grow. So if you hear new construction and it's below 4, they probably need a potential acidity test where they learn literally they've got to bury their lawn white and then have it tilled in, worked into the soil before they can establish a lawn. All right. Maybe enough of that. How am I on time? Okay. This is about 15-year-old data. I bet you still holds. So here's some graphing of pH levels. The front one is commercial farm samples. It sort of forms a nice bell-shaped curve. And that tells me farmers, these maybe professional growers are knowing what they're doing. And that's a good thing because their livelihood depends on it. And because right in the middle is where they want their pHs to be. If they want growing alfalfa, they want to be up here, it may be here or here, but they're right where they want their pHs are falling out. The middle column here says lawn and garden. Well, that's pretty much a level. So that pretty much tells me lime applications all over the place, from not applying any in here, applying the right amount, to maybe over applying it here. And the back one are garden samples, where it just pretty much shoots up and it's here over 7. So they're gonna have micronutrient problems. So a lot of times it's a small garden and they get into, well, I apply some lime every year. So it's just sort of like trying to drive the pH down. You're driving the pH too much up. So a good chunk of these garden samples, they've over applied lime. Now, another situation I've ran into is like, oh yeah, I got a wood burning stove. Well, they always put those wood ashes on the small garden or something. It's like, well, wood ashes, besides adding potassium, is what you call potash. So adding potassium will raise the pH. It'll take twice the weight, and ashes are light, but twice the weight of ag lime to do the same amount, but it will raise it. So if they're constantly adding wood ashes, and I think I got on the report now, first thing you do, stop putting wood ashes and lime on the soil to lower your pH. So, all right, what else I got here? Oh, like to come up with a lime recommendation, it will look at your soil pH. That tells you the current pH with like the roots are seen. It could be, I don't know, what is that? It'll look something between 5 and 6. And if it's for a lawn, with target pH maybe 6.5, or a lot of it's here 6.2, tells us where we want to lime up to. So if your soil pH is below our target pH, in our recommendation, we want the report not to say no lime. Well, if it's above it, we say no lime needed. And in other words, it probably means no lime needed and don't apply any. So, but if it's below it, then it continues to calculate, well, how much lime to apply. Down here in the results is the soil pH. Again, that tells us where we are. The buffer index, buffer pH, if we need to tell them how many lime, that tells how much lime to apply. The other thing that can affect the lime application, we ask on homeowner forms too, if they put something more than 0 and less than a year and a half when they applied that lime, we will give a lime credit and subtract that from what we calculated from our test results where that lime should be. I think I went through this stuff on a report. And then the next section, sample history. That's all information that was provided to the lab. Well, we may calculate this, but soil map units, that's all provided to the lab and helps with recommendation. The next middle section here, sort of the lab test results. And I think I got some other slides showing that. And then below are the recommendations. I think I've got more, but here, this section could affect the lime recommendation. And okay, so again, if it's a landscaping situation, the main things is keep pH in the right range, so follow the lime recommendation. On a farmer form, the lime and fertilizer is going to be here. For a homeowner, it will be a complete fertilizer noted, and the lime recommendation will be down in the comment section. We don't test for nitrogen for a reason because it's so mobile. It's one thing by the time they sample it, by the time they get a good leaching rain, they get the test results, it's changed again. So, but we couldn't recommend how much nitrogen, because if you tell us you're growing corn on these soils, we know you should expect this yield, it takes this much nitrogen. If you tell us you're growing grass, you're growing a lawn, if it's we know how much nitrogen should be on there. We do need to know if it's a warm season or cool season lawn. If it's a warm season lawn, like Bermuda grass, you can, I believe, more nitrogen on the cool season. And also, you most definitely put nitrogen on earlier in the calendar year than the cool season lawns or late summer or in fall. And again, I said keep P and K, phosphorus, potassium out of the low range. So there's the number we report, there's the rating. Again, soil test note 1 explains L plus and things, gives sort of what's considered medium. Magnesium, calcium, usually you don't need this unless you need lime. So when you lime, you're adding calcium, magnesium. Most likely in the state, you're applying dolomitic lime, will add both calcium and magnesium. The rest of these are micronutrients. On a landscaping situation, lawns, gardens, you usually don't need to worry about this. If the pH is kept in the proper range, then the micronutrients will take care of themselves. The extra tests, special tests, the soluble salts results would be here. Here's the organic matter results. But And then on the second line, again, were the two pHs. And most of that second line are calculated values, like this estimated CEC in milliequivalents per 100 grams. Yeah, I do get into that some. Okay, and I'll get into most of this is not useful to most people. This is probably more the professional crop advisor, and even that's for a limited use. So it's there. They're just calculated numbers, so no extra cost and time. We can provide that information. Most time, you can probably ignore that. If you want to know more about it, in a nutshell, note 1, explanation of soil test. It talks about a cation exchange capacities and estimated CEC. A direct measurement's going to, if you have that, it's going to take you more in time and money. If you didn't pay more in time and money, the lab's just estimating it. And it could be erroneous, it could be false. If the pH is too high, or if it's alkaline or excessive salts, you could be getting cations we're measuring from another place. But most time you don't need to know that. It does give you an idea of the clay content, because the charges mainly come from clay, not sand and silt particles. If I hear a CEC less than 3, in this state, I'm thinking I'm dealing with sandy soils. They call me up, they're probably in Southeast Virginia. There's other things about the potassium saturation. I don't want to go into that. You just want to use those in a gross nutrient. Look for gross nutrient imbalances. Some people get into nutrient balancing, base cation saturation, and get all tied up in that. Probably costs more in time and money. And we give fertilizer recommendations based on a sufficiency level concept. That's another talk. Yeah, I just want to talk for another couple minutes maybe. So, but not really going to go in that anymore, except most of these numbers here, you can ignore most of the time. So if you don't know how to use it, then you probably don't worry about it. Oh, that pretty much was it. Again, we always try to direct people back to the local extension office for more information. A lot of times in the library or somewhere, they do soil testing, and it's like they send us, some leaves that don't look good, and it's like, no. We don't do anything with plant tissue in this lab. And it's like there is other parts of the extension, which we're going to get into the next few weeks. And so I always redirect them back to the local extension office. I often use the analogy is their local extension agents like their primary care physician. So, and they know a little bit, at least a little bit about a lot of things, but they may sometimes need to bring in an extension specialist to answer things. And oftentimes you don't need that. The master gardener, I'd say, is like your nurse practitioner or something. They can answer a lot of questions, and they know the local situation more there, the weather or disease going around right now, or your local stores, what's available, what products, or your lawn garden stores in your area. So I try to send them back. And again, a lot of our people know that Virginia Tech does soil testing, but they don't know about Virginia Cooperative Extension. And we try to correct that and tie them back to your master gardeners, and that they know there's other labs. We just maybe the lab, like analogy, do the blood testing, we just do, or maybe breaks down there, but we're just on the labs. And a lot of times you get lab results, you call your doctor's office, not the lab. So, and if you have questions or things just break down, we always let people call the phone in the office area of the lab, area code 540 for this, 231's for campus, and then 6893 is that. Or you can email us at soiltest@vt.edu. If you add an ing to soil testing, it will come directly to me. So that will work. It doesn't work well when I'm like out giving talks like this or something. So, and that was the last question I have. And hey, I wanted to talk about an hour, and that's about 2 o'clock. Sometimes you never know. I will stop sharing my screen. So you should be seeing big, beautiful me now, right? So I'll let you, Kathleen, maybe coordinate what do you want to do now? So questions?
Great. Thank you so much, Steve. That was a really informative hour, and I think a lot of good information for our master gardeners. We have gotten a lot of questions in our chat box, and I have been keeping track of them as best as I can. So sorry to anyone whose question might have gotten lost. I'm going to get through, we can try and get through as many as we can until 2:15, if that works for you, Steve.
Yeah.
All right. The first question is, can you collect your soil sample and then wait for a while before sending in the box?
Yeah, a lot of it, we're not testing for nitrogen or what form of nitrogen, which some researchers get into, what form the nitrogen in, and microbes get active, and we're not there at all. So I'd say it's good to always, soon after you sample it, let it air dry. And for what we're doing, once it's air dry, it will be stable for a long time. So now if you forget it, another year or two go by, another year goes by, more wetting, drying cycles, it's probably best to recycle. We have people say, yeah, we can go back 3 years, and your local office can look up reports for last 3 years and say, oh, from 3 years ago. And, especially if it's on sandy soil, it's like, well, it'd really be better if you resample at this point.
Great, thank you. Next question is, if there are multiple beds in the vegetable garden, can they sample from each bed and then send in one sample? Is that the best way to do it?
Yeah, I mean, generally, if you've treated that area the same, and you till it up, so tillage helps homogenize everything. You usually, no-till situation, you're not mixing it up. So it's better to probably even take from more points. But yeah, generally a garden where you've, the soil material is pretty much all the same. It's pre-planting, and you till it up. It just, you can collect several sites and get an average of what those are. And we're getting you. That's why we build things up to M+H-. If one place is lower, it's probably not going to be a point where a home garden's going to notice it. Or so I think if I understood that right, I'd say yes. This is the bottom line answer.
Great. Next question, is biochar considered for any sample report recommendations?
No, we don't have any way to consider that going in. At times it may be used, it's quite different material, maybe for like liming, and could change things. But we don't ask for it, even on the farmer's form. It's more on their end, like, well, this is what you need, and you got to know what that biochar is going to do, nutrient and pH wise, and where you're applying it. But it's not part of our input. Even like, we do ask a question of farmers field, it'd probably be like that. You're going to add manures or so. And it doesn't really change our recommendations, but it flags additional soil test note to read about manure, how you should know your manure. I would say, what is this biochar? It could really vary, what is that and what's that going to be? And so, I mean, we tell you what to apply, what nutrients, organic, inorganic, what do you want to do? That's all up to the grower, how they want to do it. So it's more on that, and then how they want to handle it. But anytime you apply any amendment, it's probably good to know, what are we applying? What's analysis of that, and what's that going to do to it?
One of our participants read that when planting plants that are native to your area, the soil should not be improved or amended. So what's your perspective on this issue? And another question came in about planting trees. So the same kind of issue is, should you let the tree adapt to that native soil?
Right. It may be someone in later weeks could answer more authoritative on that in horticulture. It's not really a soil fertility question. However, I've been around long enough, I've learned, like, yeah, they did even extension publications at one point, planting trees or shrubs. Like, you take out a big area, and then you fill in other material, backfill it in. And now they pretty much say, you use the same material. Now it's, break it up looser and have less bulk density and stuff. But trying to think the original question, but I latched on to, like, yeah, planting things you do really, like a tree or shrub. Yeah, they do say now, And there's extension publication on like planting trees and shrubs. I think now they say to backfill it with the same material. And it's less of a soil fertility question than soil physical characteristics and water movement. I learned like on Arbor Day, I think I planted a tree when I was a little kid, and I went out with a shovel and dug out a hole. And I didn't rough up the sides, and I probably the shovel made the hole I made probably made a smooth clay layer, and then I backfilled it. Maybe I did put other things in, and then I learned getting the soil water movement in soil physics class that like it would fill up and be like a pot, and there's no drainage hole at the bottom or sides of that pot. And the more of water I filled it, it went no air pockets. It looked like it was wilting. I need more, so I watered more, and I essentially just drowned the tree. So it's probably more of a water movement. Again, like you can add for garden, you're hopefully homogenizing it, you're tilling it, working it in. So like adding things. The number one thing with clay, heavy clay soils there to modify it, it is good to modify that soil maybe 6 to 8 inches down or so, or you have a build-up beds. It is good for nutrient and water movement. If it's dense packed clay, to add things. You can add sand, but you run the risk of creating cement. So usually add organic matter, but you probably, I think, horticulturists will say add one or like a 1-to-3 ratio, 1 or 2 inches of organic matter, manure, whatever, compost, well composted material on the surface, and then till it in the top 6 inches. So, and there you're okay because the whole root zone you're dealing with, you homogenize it the same. One little spot digging a pot and tree, that goes back to what I first said. So hopefully that answered the question.
Great, thanks. Considering how much vegetables can take from the soil on an annual basis, why is it not recommended to test one time a year, rather vegetable beds rather than every few years?
It's probably anytime there's a large removal, and even a lot of farmers that are annual row crops, a lot of them probably, I mean, like a lot of times at the minimum, you probably want to do 3 years. If it's a lawn, it's growing well, every 4 or 5 years, if you got the new fertilizer up to where you need to be. On a garden, yeah, a situation like that, it wouldn't hurt, especially if you're doing a lot of crop removal or changing. It wouldn't hurt to do it every year. It wouldn't be good. Now, a lot of times the pH goes up. And again, if it's sandier soil, the pH, the sooner, more frequently, the better, maybe every year. I mean, a sandy soil, you can lime it up and it gets too high. And then you put on nitrogen, and next thing that creates acidity, and you just drove it down too low again, or even track it every month in a year. And pH, so at least the water pH will go up and down. You'll see a thing. So when you do sample annually, we tell it's best to sample at the same seasonal time of the year. Now with weather patterns changing, that gets more confusing. But like always, you get into the fall, keep doing the fall, in the same cycle. But yeah, for a lot of removal and nutrients and amendments, probably the more frequent soil testing would be a good idea. And again, the sandier the soil for the pH standpoint would be good to do more frequent.
How accurate are electronic soil testers that someone could buy from a catalog?
Yeah, well, one disclaimer, I don't have a lot of experience with those things, but from what I've heard from others or things, I mean, we just do things in the best way, most reproducible way we can here. And a lot of that, you do it so consistently, so you get a consistent answer interpretation. So there are some value. I don't want to poo-poo it. It's good for it's good for a ballpark area, for like a homeowner garden. That's probably a good thing. For a farmer, I'd say don't go that way when you're trying to shave $1 per acre. For a greenhouse operation, there's so many other parameters. I would say that they ought to have their their own electrodes for salts and pH and do their own testing more frequently, and every now and then send it to a lab. Now, if it's soilless media, we don't do that anymore. It should go to another lab. Or if it's less than half mineral soil, it really should go to another lab. So, but to get things in the ballpark, or somebody knows the what they're doing. I mean, some of the color development, you mentioned electronic. Well, if you just stick it in the ground, next thing you wiggle it some, and if it's clay, you just made a gap, air gap. How good a contact is it having with the soil? Next thing, I would certainly think it would be based on, it would vary of how wet the moisture is. So well, here we break it up, homogenize it, we air dry it, added set ratio of volume back. So in a very consistent pattern, it's very tight. So we're just, come up with a better number. You could also do with that, send in the same sample to us and see how it compares for like a nursery greenhouse. That would be good to see, compare what the numbers they're coming up with. So there's some value, but again, just like a lot of tests, there's a quicker, less expensive way, and there's a better way. Now we have costs of mass production, and per sample, it's cheaper to do it better way. So it has some benefit, but I wouldn't hang my hat on it and bet my farm on it as much as what we do. Hopefully that answers that. So.
Thank you. Do the plant codes on the soil test form include any USDA designated specialty crops?
USDA specialty crops. And I can't say I really know for sure what that means. So not sure what, so I guess I can't really answer that one because I'm not, it's bound to, but I'm not sure really what that's asking to really answer that.
Okay, so if the person who asked that question, if you have specific crops that you are wondering if are on the form, please feel free to type that in the chat box and we can see if there's some more specifics with that question. We have a few questions about lime. Could you clarify ag lime versus dolomitic lime on the form?
Dolomitic lime is, well, a type of ag lime is either going to be probably, it's natural calcitic or calcium or dolomitic limestone. It's broken up. So it's calcitic lime, only going to supply calcium. Pure dolomitic lime will have equal amounts, molecules of calcium, magnesium. To really make it ag lime, they go to the mine, they take limestone and they break it up to really be ag lime. It has to, by law, go down to through certain percentage to a certain mesh sieve, another percentage to even a finer sieve. And even that's going to be taking 1.5 years to react. So you just put coarse stuff out there. Trying to cycle back to the original question was what again? I mean, it was, so dolomitic lime is a type of material used to create ag lime once it's ground up. That's maybe the best answer to that.
Great, thanks for that clarification. I think our last question, since we're right up on 2:15, we have one individual who says their soil tests showed a high pH around 7.5, but they don't apply lime to their soil. So what else could be causing a higher pH in their soil?
Well, the number one thing comes to mind again is they're putting wood ashes on there. There's maybe not a lot of things. I mean, there's some manures usually drop the pH, but often they've added other things to it that can make it shoot up alkaline. It's like, have they applied anything else? I mean, there are some naturally alkaline soil materials that could be doing that. I don't know if it's against like a building and it's washed down, or I mean, it'd be questioning what else has ever been added to that. Most time will drive the soil pH down. Most about all nitrogen fertilizers, the end reaction will be, and manures will be driving the reaction down. But yeah, anything going on there, any limey material, eggshells, she cells, I think maybe can. But there are some odd, more rare situations where in Southwest Virginia, I think where there's maybe down from a slope, there's carbonates being leached down that's keeping it up there. And it's actually hard to make it slightly acidic.
Great, Thank you. And we did get a clarification about the crop codes. So for example, he listed turmeric or ginger. Are those listed on forms?
No, I mean, one is some of I'm thinking maybe ginseng right now. Some are like just need low fertility and stuff. Some of it's not really up there enough to have warranted, or no one's doing research on it. Well, a lot of times on some of those, it's good. You can just leave it and you get the test results. And then maybe some of these things like elephant onion or something, you go to Oregon, if it's a good source from like an Oregon extension office, what are they doing for onions? Now, a lot of those kind of crops, I used to know better some of the names like Andy Hankins, or I'm trying to think of some of the newer ones now. But over in the Virginia State Universities, our sister land grant university of extension, and a lot of these kind of specialty crops like that, they can maybe, you can find somebody at Virginia State, VSU, and they're going to know more about it than anybody here on this campus about it. And they could take the results and see like, oh, I like soil fertility, low soil fertility. So I know ginseng likes that. You don't want to lime it. You don't want to do a lot of things. So, but yeah, we don't have, there's still a limit compared to a lot. I've been in other states. We have a lot more crop codes than a lot of other states, because you can about grow anything in this state. To transition from north to south, mountains to coastal plain, and now getting into a lot of these new specialty crops for farmers. And we don't have everything here. So we're mainly here about generating the numbers in the lab. So it's really finding an extension specialist who knows about it. Most extension agents won't. And for those kind of crops, I'd be looking through the roster, the directory at the Virginia State University.
That's great advice. Thanks, Steve. All right, well, that wraps up our first session of IDs and Diagnoses with Steve Heckendorn from the Virginia Tech Soils Testing Lab. So thank you so much for joining us, Steve. Thanks to everyone who tuned in today. We had almost 300 participants in this session, which was wonderful. So I look forward to everyone joining us next week with the Insect Identification Lab.
Now we're good. I'll just throw in, we'll be really busy here in the lab, but even though we sound maybe grouchy because we're busy, we never mind talking to the local extension offices and master gardeners. You answer their question once, you just save 10 others or a ton of time trying to correct, because the crazy way some sample was sent in, now we got to refund $50 and they can't, and no one's happy because the sample's ruined and all of that. We like answering the questions that master gardeners have. So thanks for having me.
Thanks, Steve. Bye, everyone. Take care.
Take care. Bye.